In the previous video, we have seen how you can declare voids as well as how you can use voids. And in this video, we are going to see about vectors. So in general, what is a vector? A vector is a quantity which has both magnitude as well as direction. Well, this is the general, definition of a vector, and in Verilog, it is the same. So why we call this as a vector? And if you compare with the software languages, you can think of vectors in Verilog as arrays in the software languages like Python, C++, C, etc. So why it is called a vector in Verilog? Because in Verilog, you just don't simply design the or define the just the length of the array, but you also define the direction of this array. And that is why it is called as vector instead of an array in Verilog, as well as in VHDL. So why do we use these vectors in Verilog? Let's take a situation here. Let's say you are designing a processor, a 4-bit or 8-bit processor, and you have to send the result of something like an addition, and you have to send this particular 8-bit data into a memory. So how will you do this? If you are using a serial communication, then it will take a lot of time to send the data. So in most of the cases, we use parallel, we send this parallelly. So if you want to send this 8-bit at a time, you have two options. The first one is using a normal method, like you declare 8 Ys, and then you send uh, data to this 8 Ys simultaneously. Instead, we can use something called a vector. So while vector is used in the Verilog is for this purpose. So let's say you have 8 Ys and you have to use these 8 Ys with a single name. In general terms and in theory, we call these things as bus. So whenever you, not just in theory, but it's also practically, we call this as a bus. So, and the bus is nothing but a group of lines, which is nothing but a group of wires. So in Verilog, if we are going to define a wire using a vector, that means a vectored wire, we can simply call it as a bus. And how you can do this in Verilog is you can simply do wire as we do it in the general wire, and then I'm going to give a name something like a bus. Let's say bus. Now, if we are going to define it this way, why bus? That means there is only single wire. There is only one wire which is named as bus. Now, if I want to increase the length of this, bus, then we can simply use square brackets. And inside the square brackets, we have to give the length of this bus. So let's say this is a 4-bit bus. Then we can simply use 3:0. Now, this particular statement says that there is a bus named bus. I'm going to change the name just to remove the confusion. I'm going to give it as a data bus just in case. So now this particular statement says about there is a bus named data bus which is 4 bits long. So this particular you know thing says about the data bus is 4 bits long. So you can see that the LSB started from 0 and the MSB is at third position. These are the position values. These are not the data values. So whenever you see this 3 and colon 0, that means it is the range. It is starting from 0 and ending at 3. So there are 4 bits, 0, 1, 2, and 3. And whenever we are declaring a vector as this way, that means 3 colon to 0, I'm going to say this colon as 2 because, for the sake of understanding. So I can say simply 3 to 0. So whenever I'm declaring this vector as 3 to 0, that means the 0th bit is the LSB, right? So the direction of this particular data bus is from right to left. If I change this to something like 0 to 3, the direction of this data bus will change. So now the direction of data bus is from left to right. That means the most significant bit is the first bit and the least significant bit is the last bit. But if you take the binary in general theoretical way, you already know that whenever we are writing whenever we are writing a weighted code like 2 power 0, 2 power 1 and stuff, you take LSB as the first bit. So in most cases, we don't use this kind of notation. We only use this kind of notation here. So this is how you declare a vector, which is a wide vector. That means a bus. So we can simply call this particular data bus as a bus. Now, we know that this is how the bus is designed. Now, what about registers? Let's say let's take the same example, a 8-bit processor. In a 8-bit processor, we have generally 8-bit registers, general purpose registers, right? So how can you define these 8-bit registers? Well, we use the same syntax, but instead of wire, we use a register. A register, let's say R0. Now the register R0 is 1-bit register. And if we want to make it an 8-bit register, we can simply do 7 to 0. Now this particular R0 register is 8-bit size and the direction goes from right to left. So this is the basic understanding about vectors and how you can initialize and use vectors. These are very useful when you design complex circuits like processors or serial and parallel communication chips and stuff. So now how you can access the data. So let's say we have this so-called data bus, a 4-bit data bus, and I'm going to send uh, some data. Let's say 4-bit data, and it's gonna be, let's send 4 here as well. So I'm sending the 4-bit data, which is 0100 into the database. Now I want to access this particular one. That means the position of this one is 0, 1, and 2. So I want to get the you know third bit, which is at position 2, and I want to assign it to the y. You can do this in same as in programming languages like C or C++. You can simply do data bus, and you can specify the index inside this. So it is in the second position. So I'm going to do it with 2. So now if I save this and if I run this simulation, let's wait for the simulation to done. Okay, now it is done. And now you can see that the y, don't mind about a and b, we didn't use a and b anywhere here. So if you see the y, it is 1. And the data bus of 2 is, this is 0, this is 1, and this is 2. So data bus of 2 is basically 1. So the output is obviously 1. Let's change this to maybe 3, and this is the 3, right? So if I save this and if I rerun this simulation, let's see what we get at the output. So if I go to the output, you can see that the output is 0. There. So this is how you define the vectors and this is how you get the particular data. Data is particular position in your vector. So vectors are very useful when you are designing the complex circuits and whenever like I said, when you use buses and multiple bit registers, right? So we are going to see about these vectors in depth in the next video. So until then, peace.